Finally, we're going to look at three structures. The first is called a simple cycle. And what's a simple cycle? Well, it's a cycle that repeats only the first and the last vertex. So to be a cycle, it's got to repeat the first and the last vertex, but I cannot repeat a vertex inside the cycle itself. So if you'd like an example of a simple cycle, let's look at this graph right here. And here's the simple cycle. V1 goes to V2, goes to V5, back to V1. So the point is, I repeat V1, the beginning and the end, but I don't repeat any vertices in between there. That's the example of a simple cycle. Now, an example of something that's not a simple cycle is, like we saw in the last video, if I look at this graph again and I go from V1 to V2 to V3 to V4 back to V2, so I repeat V2 twice, then V5 and back to V1. That's a cycle, like we saw last time, but it's not a simple cycle. And the reason it's not a simple cycle is because I go V2 here and V2 there. So there's an example of a simple cycle. Now I want to talk about the degree of a vertex. The degree of a vertex is the number of lines going into it. Notice I don't say the number of edges incident on it. And the reason is that a loop, which is just one edge, counts 2 to any degree. So let's look at a particular example. Here's my graph. This symbol right here is delta, and delta stands for degree, so you can read this as the degree of V1. So I look at V1, I see how many lines that go into it. There's only one line, so the degree of V1 is 1. Now, if I want to know the degree of V5, well, V5 is sitting right there. What is that? An isolated vertex, which means there is no edge incident on it. Therefore, the degree of V5 is 0. Now, if I look at V4, V4 has a loop on it, E4. But look, how many lines are going into it? The answer is 2. Now, how many edges are incident on it? The answer is just 1. But since there's 2 lines going into it, the degree of V4 is 2. That goes back to what I said here. A loop contributes 2 to any degree. Finally, if I want to look at the degree of V2, let's go to V2. And I see there are 3 lines going in. Therefore, the degree of V2 is, in fact, 3. All right, so there's the concept of degree. Now we're going to talk about an Euler cycle. Now, what's an Euler cycle? It's a cycle that includes all vertices and edges. So it's a cycle, and once I go through it, I go through all edges and vertices. Now remember, to be a cycle, I cannot repeat edges. Now there's only one exception to an Euler cycle, and that is that a graph that only has one vertex, period, is also considered to have an Euler cycle, even though, okay, if it just has one vertex, then it can't possibly have a cycle of positive or closed path of positive length, which is the way we define a cycle, but we still say it has an Euler cycle. All right, so here are a couple of examples of graphs, or at least of a graph that has an Euler cycle. That is, a cycle that goes through all edges and vertices. And here goes. So I go here's the cycle, V1 to V2 to V3 to V4 to V2 to V5 back to V1. It's a cycle. It's not a simple cycle because I've repeated V2, but that's okay. It's a cycle that does what? Goes through every vertex and every edge. There's an Euler cycle, and I give it to you right here. Now, in the next video, we're going to explain why this graph, which by the way is what? K4, does not have an Euler cycle. I claim there's no cycle that you can come up with that goes through every edge and every vertex. And the reason is you would have to repeat an edge. But like I said, we're going to talk about that in the next video. So that's it for now. Bye.